Okay, we're now ready to apply the DOSY transform step. Now, if your data are JEOL data, JSON will automatically detect that these are DOSY data and add the DOSY transform step as the final step in your process list, as we see here. If your data are non-JEOL data, then you will probably have to add this step manually, and we'll cover that in another video. Okay, so we've got the DOSY transform step here. Let's explore the various options in this processing step. So if I click the right hand button, the down arrow, we can now see the various options. To enable the DOSY transform, just click the DOSY transform checkbox on the left hand side. So let's look at the different parameters and options in the DOSY transform step. The first one is fitting. And there are 3 different options available to us. There's DOSY by peaks, DOSY by integral, and DOSY by points. Now, DOSY by peaks is the most widely used option. This will do automatic peak picking and will then fit the peak amplitudes to the statistical Tanner equation. DOSY by integral will instead use integral regions, so it will do automatic integral finding and then fit those integrals to the statistical Tanner equation. Finally, we have DOSY by points. Now, this is the lesser used of the options, but can be useful for diagnosing issues with the data. And what this does is to use a certain number of points, so within a region of the spectrum, all of those points within a region, and fit each of those points to the statistical Tanner equation. With the example data I've got here, I'm going to use DOSY by peaks. The next parameter here is the Tesla per meter factor. Now, this is a conversion factor from the units used for the gradient strength in your data to Tesla per meter. Now, if you're using JEOL data, this parameter should be set automatically and you shouldn't have to worry about it. If you're using other vendors' data, it may be necessary to adjust this parameter to get the right conversion factor. Then we have the lowest diffusion coefficient and the highest diffusion coefficient to show in the final DOSY spectrum, the range of our DOSY spectrum. Then we have the number of points to use when doing the fitting. So this corresponds to the number of increments in our DOSY data set. So the DOSY data I have here, there are 30 increments in the gradient amplitude. We can reduce that number and essentially use fewer increments if we want to. Then we have digitization. This is the number of points used to construct the DOSY spectrum in the diffusion dimension, in the diffusion coefficient dimension. If we increase the number of points, the resolution, or the digital resolution in the diffusion dimension will increase, but it will take longer to generate the spectrum. Then we have ListName. This is essentially a parameter that holds the value of the parameter that is arrayed in your data. So normally you don't have to play around with this parameter, but if you don't get quite the right result, or the experiment isn't working, the processing isn't working, you may need to make sure that this parameter is actually correctly set for the data that you have. Then we have the magnetogyric ratio of the nucleus that is involved in the diffusion encoding. So here we have the magnetogyric ratio, or gamma of the proton. Then we have the diffusion time. This corresponds to del or big delta in the statistical Tanner equation. And again, if you've got JEOL data, this should be read automatically from your data. Then we have the diffusion pulse duration, or little delta, in the statistical Tanner equation. And finally, we have some options that relate to the shape of the gradients used for diffusion encoding. So you can select from rectangular, half sign, or you can define a user-defined shape function. And the data I have here, the diffusion encoding gradient pulses were rectangular, so I'm going to leave that set as it is. If you had half sign gradients or some other shape gradients, you would need to adjust this parameter accordingly. And this parameter, or the setting of this parameter, will affect the shape factor in the next field. So if I choose half sign, that will change that shape factor to 0.63, which basically corresponds to the ratio of the areas of a half sign function versus a rectangular function of the same duration and amplitude. So I'm going to set that back to rectangular. We're now ready to apply the DOSY transform. So all I need to do is click the apply button, and we will now get a DOSY spectrum in our display. Now I can increase the vertical scale of the DOSY spectrum by rotating the click wheel away from me. And we can see more of the peaks. If we want to put a diffusion projection on the left-hand side, we can do that by going to the View tab, and then from the Side Views section, enabling the vertical option, and that will then display a diffusion projection. Okay, so we now have our DOSY spectrum. Thank you for watching this video. We hope you found it useful. For more information about JSON, please visit our website www.jailjason.com, where you can find links to other videos and start your free trial.